Hi, I'm Adam, founder of HeatGeek, the UK's leading heating experts. I'm here today to ask Nick, how are you going to decarbonise your businesses? You have offices, showrooms, and manufacturing plants, right? Just walk us through those. Specifically the manufacturing plants, I'm interested in how that's even possible.
Let's start with the simplest, is here at the showroom on Fulham Road in London. Today we've got Wes here from West Hampstead Heating. He's already taken out the gas combi and he's putting in an EV heat pump.
He's also a heat geek, we might add.
He is also a heat geek, an elite heat geek. So here we're sorted. We're already on a 100% renewable electric tariff and that's all good. In Stockport, where we're based, where our HQ is, we've got 3 gas combi boilers. We have numerous gas infrared catalytic heaters, which we use to preheat the radiators before they're painted. And then we have a huge, great big convector oven to do the final cure. That's going to be a real challenge. So let's start with the heating. We have 1970s construction, poorly insulated. The construction really is not good. But we have the advantage of being able to access lots of radiators. I think that taking out the gas combis and putting in a heat pump with our existing radiators would be possible, but we'll probably achieve relatively low efficiencies. So to combat that, we're going to increase the size of the radiators, which is not a problem for us. We're not going to do any fabric improvements right now, but we will look to do that in the future. The preheating of the radiators, now that is possible to do electrically, absolutely possible, but we're right at the limit of the electricity that we've got available in the factory. We run shot blasters, we run machining, CNC machining, we run lathes, all sorts of things, and we're right at the limit. One way that we can do it is we can actually use a heat pump to heat the paint that we dip into rather than heating the radiator before it goes in. We're going to do that by wrapping copper pipe all the way around a steel tank, which preheats the paint to heat the paint that's warm, not the radiator. Afterwards, the cure, well, we've realised that in fact, it's not so much the temperature, it's more about the airflow. So for our convector oven, we're hoping, we're in the process of doing it, and our trials show that it works really well. In fact, we're going to use an air-to-air heat pump with very high air changes to ensure that we've got a really dry environment where the radiator's curing, and we're just going to go low and slow. So it only needs to be about 13 degrees C, but over a 12-hour period, we're getting fantastic results on a really solid cure using a really fantastic paint. And actually, what we're finding is that paint comes out of the low-slow cure harder than it comes out of the 120 degrees C short, high-temperature cure.
Amazing. And so local electricity, is that kind of expensive?
Yeah, so it's spiked. Electricity costs have really spiked. We're insulated from it a little bit. It's about 25% of our electricity is generated by solar, which we've got on the roof.
Amazing.
We are on a renewable tariff, which is a little bit more. What I would like to look into is a time of use tariff, because a lot of our processes, for instance, compressing air, can be done more smartly. So by storing compressed air, which just by a few more tanks, I'm hoping that we can offset some of that electricity use to the night time. Things like our forklift trucks, they're all electric. We charge those at night time. By offsetting use to periods of time when it suits the grid, I think we can quite dramatically reduce what we're using during the working day.
Amazing. So you receive the radiators already made? Like, where do they come from? Are you partnering there, or how's that part done?
So we design molds in the first instance. We then send those molds or send the patterns to a foundry. The foundry then creates the mold, pours the metal into the mold, and then sends us the components, which we then machine, thread, assemble, test, paint, and send out to the outside. The foundry partners that we work with, we choose them really carefully. It has to be really high quality. Since 2020, we've been trying to onshore as much of our casting as possible. We were working with a company in Walsall, and really regrettably they went bust. So we then moved our production to another foundry in Poole in Dorset. Great thing about them is that they use 100% renewable electricity from the wind farms that are just offshore there. They use 96% recycled metal goes into their furnaces, and they have an on-site sand recycling plant which allows them to reuse much more of their sand than most foundries. So they're a really, really sustainable foundry. In fact, They won a recent award in 2019, I think it was, for their sustainability. Their quality is next to none. It's just amazing.
That's amazing. So other types of cast iron radiators, are they made in the UK, or where are other ones made?
So there are 3 major foundries in China. There's 2 radiator foundries in Turkey. We use a couple of radiator foundries in Turkey. They're really, really good quality. We're the only people, as far as I know, casting in Britain as well.
So that would obviously have a much higher, if you was outsourcing from China, much higher carbon footprint.
Yeah, for sure. In fact, we did a lot of work on the carbon footprint. The shipping is a relatively small element to the carbon footprint of a product. The important thing about products really is that we buy once and we don't buy again. Our radiators, we make them so that they last centuries. In fact, we're sat right here next to 100-year-old radiators. These have been going strong since, end of the Victorian times. Yeah. We're making our radiators in exactly the same way, using the same type of gaskets. The only real difference is that we don't use asbestos in our gaskets, but we do use a non-asbestos fibre gasket. Machined, it's threaded exactly the same way.
Which is the opposite of how traditional modern panel radiators are designed. The metal's getting thinner, they're rusting a bit quicker, losing quality. So that's very much the other end of the scale.
Absolutely, yeah.
What it happens also. Wow, so offices being decarbonised by removing the 3 combis that are there.
3 combis,
the gas.
Yeah.
Showroom being done in the background.
Absolutely.
Your industrial processes being decarbonized, and the foundry that you source the.
Yeah.
Wow, that's really admirable.
We've got a lot more work to do. We're not there yet. The foundries aren't all renewably powered, but they are all electrically powered. So we're reliant on the mix there.
Instead of using gas, they use electricity.
Well, the alternative is an old-fashioned coal furnace.
And so how does electricity heat up metal?
It's induction.
And they use induction, same as a pan on
Just like a pan on a...
Oh no, that's really amazing. Yeah. Well, what drives this? Is this your passion you're passionate about?
Yeah, so at university I studied geology, and way back then we were talking about the climate emergency and carbon sequestration. This was 20 years ago. I've seen very little happen since. The reason that I'm so enamored by what you guys are doing at HeatGeek is because, you're making a real difference. You're making a real difference. Home heating is a big, big part of the UK's CO2 emissions, and we are able to do something about that right now. And we're not moving quick enough. We must move quicker. And as an industry, as a small player, but a player nonetheless in the heating industry in the UK, I feel it's my moral obligation to show that it can be done, and I'm starting that with my own business and my own home.
Well, Nick, I've got to say that although you're making this pledge to decarbonise the business, it sounds like you're well ahead of nearly all of the competition anyway, and you didn't need to do that with this product specifically. So this just goes to show how much detail and how much further you go beyond. So I'm really happy that we're in a partnership with yourselves. And very impressive, and I look forward to see how this all grows.
Thank you very much.
Thanks.
Cheers, Adam.